Hello and welcome to this webinar on the exciting new features in nRF Connect SDK version 1.5.0. I am one of your hosts today. My name is Bjørn. I'm a product marketing engineer at Nordic Semiconductor, and with me I have Krzysztof and Joakim. They are both technical product managers. Krzysztof works on the short-range wireless side, and Joakim works with our cellular IoT products. Just some quick practicalities before we start. The duration of this webinar will be approximately 45 minutes, and then we'll have a 15-minute Q&A at the end. Questions are encouraged. Please type the questions in the top of the right sidebar here. You should see Ask a Question. All questions are anonymous. Please try to keep them relevant, and we'll answer it towards the end during the Q&A. The chat, which is below the questions tab, is not anonymous and should not be used for questions. If you have any more questions after the webinar is done, feel free to go to devzone.nordicsemi.com and ask your questions there. And a recording of the webinar will be available together with the presentation at webinars.nordicsemi.com after the webinar is done. Content-wise, I'll just give a short intro to the nRF Connect SDK, and then I'll hand it over to Krzysztof, who will go through some short-range updates on version 1.5, and then Joakim will talk about the Cellular IoT updates in version 1.5. And then last but not least, a Q&A at the end. So just a quick intro to nRF Connect. That's basically our umbrella of tools to help developers build and debug their applications quickly. So Connect consists of the nRF Connect SDK, which is the focus of this webinar today, and then also the nRF Connect for Desktop, which is essentially a desktop suite of tools to help in development. We also have nRF Connect for cloud development and also testing, and mobile applications, which are some mobile applications which will help develop products quickly. So just a quick intro to nRF Connect SDK. It is all in one place. It is one code base and toolchain for the nRF 91 series, nRF 53 series, and nRF 52 series. It is optional for the nRF 52 series, so there you can either choose to use the nRF Connect SDK or the nRF 5 SDK, and this is since the version 1.3.0 tag that you can use the nRF 52 series and nRF Connect SDK. Protocol support-wise, we have LTM support, narrowband IoT, Bluetooth, including Bluetooth Mesh, Thread, Zigbee, and also GPS. And the version 1.4.1 tag introduces a Bluetooth version 5.2 qualified host and controller. Codebase-wise, this includes app code, connectivity protocols, wireless stacks, and peripheral drivers. As you can see from the figure on the right, we have some code which is blue and some that's purple. The blue code is the Nordic specific code, so that's code that we write ourselves, and the purple is open source code, such as the Zephyr RTOS, for example. So the code is organized into 4 main repositories. So you have the nRF repository for applications and connectivity protocols, nRF xlib, which contains peripheral drivers and stacks. It also contains RTOS agnostic libraries, so RTOS independent libraries basically. Zephyr includes the real-time operating system and also some board configurations, such as device tree, for example. And then you have MCU boot, which is an open source secure bootloader. So here's just a quick intro to some of the basic terminology. Git is essentially, you're probably well aware of what Git is. It's an open source distributed version control system for managing source code changes. This is very useful, seeing as we do have multiple repositories, so Git makes it very easy to figure out which tags and which commits fit together. West is a Zephyr-specific tool, and it's a command line tool for multi-repository management and also building and flashing examples. So with Git, you can choose which tag you want to check out, and then you can use West to then basically update all of the other repositories to use the correct commit for that tag. Repository is essentially a version-controlled project folder, for example, nRF or Zephyr. And every code commit creates a repository version with a unique secure hash algorithm identifier. So that is very important. Tag essentially just points to a specific commit SHA identifier. It is immutable, so it doesn't change. And the main difference between a commit and a tag, or one of the main differences, is that a tag is human readable. So instead of being a jumble of some random identifier, it could be, for example, version 1.5.0. That's a lot easier to read. And for a tag, Nordic product development support is available, but I'll talk a bit about that later. Master branch points to the most recent commit SHA, and that's mutable. That's always changing. So that's always pointing to the most recent commit. And master branch can be used if you want to start testing newer features earlier on, for example. So just a quick intro to upstream versus downstream. So basically, upstream basically means that the flow of information is upstream towards the source. So for example, from developer B to developer A to master. So that would be a pull request, for example. And downstream is when the flow of information is downstream from the source. So in this case, from the master branch to developer A to developer B, for example. So if developer A, for example, decides to check out the master branch, the latest commits, it can check that out and do a West update, and then the flow of information will be downstream. So that's just a short intro to what the difference is between upstream and downstream. Documentation-wise, we do have a link to the documentation, and this will be available in the PDF presentation afterwards. So one of the main things is that on the upper left-hand corner, you do have an arrow to choose the documentation tag. So this one here. And there, when you click on that arrow, you'll get a drop-down menu. And this is where you can choose all of the different tagged versions of nRF Connect SDK. So latest refers to master branch. Sometimes you might also see 1.5.99. That also refers to master branch. And as of right now, the latest tag is 1.5.0. And on the bottom left, you should see something similar to this. If you click on that arrow, you will also get a drop-down, which then includes all the different repository documentation. So for nRF-xlib, Zephyr, MCU boot, kconfig, etc. And here you can also see then which tagged version of, so which commit of nRF-xlib and Zephyr and MCU boot, I guess which tag is being used for the specific nRF Connect SDK tag. Source code and configuration, just a quick intro to that. West, like I mentioned, is a multi-repository management tool that can be used for cloning and updating. So here you have the code base, the nRF Connect SDK code base, and then you can add your code in a separate repository. That then becomes the code base, dependent on the west.yaml file. Then you can use kconfig for source module and feature configuration. So there you can set the different features. For example, if you want to use GPS, for example, if you want to use MQTT, etc. Yeah, you can set all of the different features in kconfig. And this can then be done without changing any of the source code itself. So this can easily be done in a project config file, for example. And then last but not least, you have the device tree, which describes the board target itself. So that's how you configure the target. So the device tree files, they'll be different, slightly different depending on whether you're using a Thingy91, for example, an nRF52 dev kit, or a mouse reference design. Release cycles. So nRF Connect SDK is released on a quarterly basis. Version 1.5.0 was released maybe 1.5 weeks ago. It is publicly hosted on GitHub, and fixes are released as needed. So even if it's a long-term supported release, it can have fixes applied and delivered after new releases. So for example here, as can be seen down here. And the latest development version is available, so that is the master branch. And version control management is done with Git. So if you want to manage new versions and also fix adoption. And the tool also supports merging. So we do have both major tags, minor tags, and also bug fixes in addition to the master branch. So just a quick intro on what is supported for development and what is supported for production and what that means. So features that are supported for development can be used for development, but are not recommended for volume production. So tech support is available. Reported bugs may not be resolved until it is supported for production. Implementations could be partial, and APIs may change, also going to production, and verification is incomplete. So this is very good for prototyping and evaluation. Features, on the other hand, that are supported for production will be maintained and are also suitable for product development. Again, tech support is available. Reported critical bugs will be resolved in both the master and latest tag version of nRF Connect SDK. The implementations there are complete, and this is verified for product development. So this is very useful for production. So it is suitable in end products. So just a quick intro on some of the protocols and what is supported. So on Bluetooth Low Energy, all nRF 52 series SoCs are supported for production. The nRF 5340 SoC is supported for development. We do have complete Bluetooth version 5.2 qualified protocol stacks with all of the features. So whether that be high throughput 2 Mbps, channel select algorithm number 2, long range advertising extensions, broadcast peripheral observer central multi-role. We also have LE secure connections, privacy 1.2, and data packet length extension. So this is a fully qualified version 5.2 protocol stack. Bluetooth mesh, we do have development support for the nRF 5340, the 52840, 52833, 52832, and 52820 SoCs. Samples from both Nordic and Zephyr are available. All of the Bluetooth mesh models are implemented, and the Bluetooth mesh profile version 1.0 stack includes all of the mandatory and also most of the optional features. So we do have Node, both advertising and GAT bearer, relay and proxy server features, friend and low power features, and also configuration and health foundation models. So that's all included. On the thread side, there's support for production for the nRF 5340, 52840, and 52833 SoCs. There we do have samples for CLI, CoAP client, CoAP server, and NCP, so network coprocessor. There is dynamic multi-protocol with Bluetooth Low Energy, and single SoC and network coprocessor architectures too. And for the OpenThread thread stack, it is Thread 1.1 certified, and we do have support for router, border router, and sleepy end device roles. On the Zigbee side, you have support for development for the nRF 5340, 52840, and 52833 SoCs. We have samples which include light bulb, light switch, and NCP. Again, there is support for dynamic multi-protocol with Bluetooth Low Energy, and there is single SoC and also network coprocessor architectures. And for the ZBoss Zigbee stack, it supports Zigbee 3.0, and coordinator router and sleepy end device roles are supported. So without further ado, I will hand over for the short range updates on nRF Connect SDK version 1.5.0.
Hello, my name is Krzysztof. I work as a technical product manager for short-range wireless, and today I would like to present you exciting new features regarding short-range wireless protocols and some exciting new protocol-independent functionalities in nRF Connect SDK 1.5. The newest addition to our short-range wireless portfolio is nRF 5340, which is a dual-core SoC. The application processor is optimized for performance and allows you to perform time-critical application tasks without being affected by radio stack execution. The network processor is optimized for low power and efficiency and responsible for radio operations. Additionally, nRF 5340 provides the advanced feature set and an operating temperature up to 105 centigrade. Combination of those features make it an ideal choice for early audio, professional lighting, advanced wearables, and other complex IoT applications. In December 2020, we released a production version of nRF 5340, available now through Nordic's distribution network. While for nRF 52 family, you have a choice which SDK to use. You can either use nRF 5 SDK or nRF Connect SDK. nRF 53 family is supported only in scope of nRF Connect SDK. NCS 1.5 introduces support for nRF 5340 development kit, so nRF 5340 DK. The nRF 5340 preview development kit, or PDK, is deprecated now. nRF Connect SDK 1.4 was the last to support the PDK. So if you want to know if you have a PDK or DK, check the version number present on the sticker on your kit. If the version is 0.11 or higher, the kit is an 5340 development kit. If the version is lower, it means you have preview development kit with an engineering version of the SoC. nRF Connect SDK 1.5 introduces for production support for Thread networking protocol and delivers for development support for other short-range wireless protocols and multi-protocol operation. We plan to introduce for production support for Bluetooth Low Energy and for Thread plus Bluetooth Low Energy multi-protocol operation soon, and follow up with adding for production support for Bluetooth Mesh and Zigbee later. In nRF Connect SDK 1.5, we have completed implementation of all models present in Bluetooth Mesh model specification version 1.0. They are supported for development. To achieve that, we added light XYL models, which provide control over color changing lights using CIE 1931 model of color representation. We added HSL models, which provide control over color changing lights using the hue saturation lightness model of color representation. We added scheduler models. Certain types of state changes can be scheduled to take place at a specific time every day or on a specific day of the week. This is made possible by a set of scheduler models. We also extended options for the Bluetooth Mesh Lite and Bluetooth Mesh Lite switch samples by adding support for nRF 52833 DK. Finally, we plan Bluetooth SIG qualification for the Bluetooth Mesh solution, which is present in the recent release. We also optimized memory footprint for some of samples present in the SDK. The peripheral UART sample demonstrates how to use the Nordic UART service to send data back and forth between a UART connection and the Bluetooth LE connection emulating a serial port over Bluetooth LE. We added minimal configuration to this sample, in consequence enabling Bluetooth support for nRF 52810 and nRF 52811 devices. We also optimized memory used by thread samples. Finally, to facilitate development for the most resource-constrained devices, like nRF 52810 or nRF 52811, and to facilitate more efficient memory usage for bigger SoCs, we added documentation on how to optimize ROM and RAM footprint when developing a Bluetooth LE or Thread applications. The guide can be found in application development section of NCS 1.5 documentation. nRF 5 SDK for HomeKit was Nordic solution for HomeKit over the course of many years. Now this SDK is deprecated and will not be upgraded to recently released HomeKit accessory development kit version 5 or any future version of the ADK. It is worth to mention that it is not possible to obtain a HomeKit certification for a new product using the nRF 5 SDK for HomeKit because it is based on the deprecated ADK version 4. So let me introduce what has happened recently in the HomeKit ecosystem. The history of HomeKit has emerged with two wireless connectivity options. Wi-Fi for the high bandwidth, low latency mains powered communication, and Bluetooth low energy for low bandwidth connectivity with low power requirements. In November 2020, Apple released to MFI program members the extended specification of HomeKit accessory protocol to add support for Thread as an additional connectivity option. This was timed with another major release from Apple, the HomePod Mini. This device is Apple's first home hub supporting the Thread networking protocol natively. The nRF Connect SDK is Nordic's default solution for HomeKit today. This solution is going to be developed and improved long term and will integrate all future versions of the ADK. It supports creating both HomeKit over Thread and HomeKit over Bluetooth Low Energy accessories. nRF Connect SDK integrates HomeKit Accessory Development Kit version 5. This solution was released for the first time in January 2021 and showcased integration of ADK 5.0 with nRF Connect SDK 1.4. nRF Connect SDK 1.5 integrates ADK 5.1. Currently, HomeKit software is supported for development, and we plan to release it supported for production soon. Similarly to nRF 5 SDK for HomeKit, MFI licensees can get access to the HomeKit repository by contacting us via Nordic DevZone private ticket. It is also worth noting that when it comes to Thread-based accessories, Nordic uses the same hardware and the same software platform for Project Connected Home over IP, or Project Chip in short. It allows devices built for HomeKit to run Project Chip or upgrade to Project Chip with minimal additional development effort. So speaking about Project Chip, Project Connected Home over IP is a working group within Zigbee Alliance with the goal to unify smart home by specifying a new application layer running on top of IP. The project involves engineers from Amazon, Apple, Google, Samsung, and over 150 other companies collaborating together to make it easier for device manufacturers to build devices that are compatible with smart home and voice services such as Amazon's Alexa, Apple's Siri, Google's Assistant, and others. Project Chip is a temporary name for the project, not the final name for the protocol. A name for the protocol will be announced later this year. Version 1.0 of the specification targets Wi-Fi and Thread as main connectivity protocol, while Bluetooth Low Energy will be used to add new devices to a network. Nordic is an active participant in Project Chip from day one, and we provide full support for suitable SoCs within nRF 52 and nRF 53 families. While draft specification of Project Chip is available only to Zigbee Alliance members, the implementation is present in a public GitHub repository and is available to everyone. An important remark, the project is still at an early stage and is under development. In NCS 1.5, we integrated the current state of the project connected home over IP repository. We provided a user guide for the project and few samples. Since the project code is now an official part of the SDK, support for the project is available now through Nordic's dev zone. In NCS 1.5, we added more complete support for Zigbee network coprocessor architecture supported for development. Split stack architectures are most commonly used to design Zigbee gateways, but sometimes also for complex end devices. In these designs, a more powerful host processor, which is typically Cortex A-class processor, interacts with a Zigbee network through the connectivity SoC, for example, Nordic's SoC with 802.15.4 radio like nRF 52833. In NCS 1.5, we added fully configurable NCP sample for nRF 52840 and nRF 52833, which allows to customize configuration and several parameters. As a complementary part, we deliver NCP host in source code with a reference build for Linux. Now let's talk a bit about protocol-independent functionalities, like this new exciting functionality which allows for embedded machine learning on Nordic SoCs. In nRF Connect SDK 1.5, we introduced support for edge impulse machine learning models. To be able to use them, you have to follow 3 basic steps, which we facilitate with appropriate libraries and samples. So before you integrate the edge impulse machine learning model into an application, the machine learning model must be prepared and deployed. This model is prepared using the external web tool called Edge Impulse Studio. So the first step is to provide sensor data to Edge Impulse Studio. This is showcased with Edge Impulse Data Forwarder sample. The second step is machine learning model preparation, which is executed by Edge Impulse Studio. And finally, the third step is machine learning model integration. For this, you use Edge Impulse Wrapper, which is demonstrated by Edge Impulse Wrapper sample. We would like also to discuss platform security architecture and trusted firmware M a bit. This is just a sneak peek of a broad topic. You will hear more from us this year. The platform security architecture, or PSA in short, is an initiative from ARM that aims to address some of shortcomings with IoT security. It is built on industry best practices and outlines common standards for security. The PSI defines 4 key stages. In the first stage, you analyze the threats that have the potential to compromise your device. The goal is to generate a set of security requirements based on the risks. For the second stage, which is architect stage, ARM provides a set of freely available hardware and firmware specifications to design the necessary security requirements for your product. The implement stage, which is the third one, offers an open source firmware reference implementation, APIs, and the API test suites. These collectively provide developers with a trusted code base that complies with PSI specification and APIs that create an interface to underlying root of trust hardware. And finally, the certified stage, known as PSA certified, is an independent evaluation and certification scheme developed by ARM and its security partners. So Trusted Firmware M, or TFM, is an open source project which addresses the first stage of PSA. It is a reference implementation of platform security architecture and provides a highly configurable set of software components to create a trusted execution environment. In NCS 1.5, we added basic for development support for TFM, for nRF 5340 and nRF 9160. More complete support is coming. Thank you very much for joining me in the short-range wireless part. Now I give the floor to Joakim to present exciting new features in cellular.
Okay, then it's time for the cellular IoT updates. As a starting point, we have an overview of the most important components for cellular IoT in nRF Connect SDK. Starting from the bottom, we have the modem firmware running on the modem core. It supports LTE-M, narrowband IoT, and GPS. It is a precompiled image that is distributed through nordicsemi.com. The modem firmware basically handles everything from the physical level and up to TLS, DTLS layers. Then moving on to the application core, we have the modem library, previously called BSD library. This is the main interface for operating the modem. It provides 8 generic sockets that can freely be used as UDP, TCP, TLS, DTLS sockets, and also AT commands. It's compatible with the BSD socket standard. This is to simplify your writing and porting of existing applications. The modem library also provides an interface towards the GPS, an assisted GPS, and also towards a modem for firmware updates. Above these sockets, we have the internet protocols or the middleware. This is basically using the generic sockets that we talked about to implement internet protocols like HTTP, MQTT, lightweight machine-to-machine, co-op, and more. Then in addition to that, we have what I call the ease of use utilities. It is a link controller library that's making it easier to handle the LTE link. It has 80 command libraries that makes dealing with the modem easier. It has drivers for GPS and also drivers for doing firmware updates. Then at the side there, we have the carrier or mobile network operator device management library. This is provided as a pre-certified binary and is required by some mobile network operators like Verizon and AT&T in USA, for instance. This is using lightweight machine-to-machine to realize device management. It has features like modem update, connection statistics, device status, and much more. Then on top of all of this, we have some libraries and modules that is also made to increase ease of use. Increase ease of use connecting to various cloud services like nRF Connect for Cloud, AVS, Azure. It's easy to do firmware updates, do location and GPS, like assisted GPS and cell-based location, etc. In addition to this, we have modem libraries that deals with key and certificate management, and also SMS subscriber modules. At the very top, we have the applications and samples, like asset tracker application, examples for doing assisted GPS, examples using AVS, Azure, nRF Cloud, doing just the internet protocols like HTTP, MQTT, CoAP, lightweight machine-to-machine examples, and a lot more. In addition to the samples you find in nRF Connect SDK folder, you can also use the samples inside the Zephyr RTOS folder. Then over to the nRF Connect SDK version 1.5.0 updates. First out, we have the modem library. Briefly mention that this library was previously called BSD library. It has been renamed. The BSD library had a fixed memory configuration. The new modem library have dynamically configurable memory and buffers. It's now possible to optimize memory usage for your particular use case. New default memory configuration saves more than 50% of the RAM, which basically means that you have more RAM that you can use for your application. It also has a new feature we call memory diagnostics. This is something that you can enable through kconfig, and this will help you to find a good memory configuration for your particular use case. And it's being very helpful during development and debugging when writing your application. Then on the device management side, nRF Connect SDK version 1.5.0 comes with carrier library version 0.10.2. This is the same library that was also in nRF Connect SDK version 1.4.2 and is certified for AT&T and Verizon. Also on the device management side, we have added support for doing full modem firmware updates over the air. This requires to have an external 2 MB flash. And we provide examples showing update using HTTP. Also on the full modem update side, we have also implemented updating modem through UART. This is using the SMP protocol and the MCU management protocol that's found in MCU boot project. Then on the application side of things, we have a new asset tracker v2. This is a real-time configurable ultra-low power capable application firmware for the 9160. It's a complete rework of the previous asset tracker. This application introduces a new set of features which is not present in the old application. Ultra-low power by design. This is the application that highlights how you can utilize the great power saving functionality of the 9160 system in package. This is critical to develop small form factor devices and or devices that need to operate for a very long time on battery. The new application implements a new strategy we call offline first. Highly mobile cellular IoT products need to handle unreliable connections gracefully. And this we do by implementing mechanisms to retry the failed sending of data. This new application also includes timestamping on the device. Sensor data is timestamped and sent. It also includes batching of data so that you can gather more data into a batch and then send it when you go online. This new application is also highly configurable at runtime, meaning that behavior like the accelerometer sensitivity, GPS timeouts and intervals, and such things can be configured runtime. As I mentioned, the new implementation and these features required a rework of the existing asset tracker application. So it's important to note that this new version is not backwards compatible with the old asset tracker. Then we have the supported modem firmwares. nRF Connect SDK version 1.5.0 supports both modem firmware 1.2.3, but also version 1.1.4. When to use which modem firmware, you can go into the compatibility matrix on infocenter.nordicsemi.com and see for which regions and which operators the different versions are certified for. Links to both release notes and compatibility matrix is available in the slide deck. So this is something that can be downloaded after this webinar. Also, to get an overview of all the different both regulatory and carrier certifications, you can go into our nRF 9160 certification webpage. Link is also in the presentation. Then it's time for Q&A. Thank you very much.